All right, so today we will go ahead and pick up our new unit, which is going to be based on oblique triangles. All right, we'll go ahead and start with right triangles again, though. So we did a lot of stuff with right triangles last unit. Yes, that's what I would call this unit. All right, so um, we did a lot with right triangles yesterday, which is basically just SOHCAHTOA. You can use SOHCAHTOA or you can use the Pythagorean theorem, right? A squared plus b squared equals c squared. All right, and those two things work for right triangles. Now, it says here to solve right triangles. Last unit, we really only focused on finding a specific piece of a right triangle, right? Now, when it says to solve a right triangle, that actually means to find all missing pieces. Okay, so we'll kind of expand it a little bit. All right, so we have a right triangle here. All right, and it tells us that side A is 12.3 and angle A is 20 degrees. Okay, now do be mindful that whenever we call a triangle ABC, all right, just so that it fits the Pythagorean theorem, a squared plus b squared equals c squared, all right, um, that C always has to be the right angle. All right. Also, please do remember from geometry, and we probably talked about it last unit a little bit also. All right, but angles are always capital letters. All right, so angle A, angle B, and angle C. All right, and sides are always lowercase letters. All right, so here we have side A, side B, and side C. All right, now the side, all right, and the angle across from it or opposite from it, all right, always share the same letter. All right, so angle A, side A is across from it. Angle B, side B is across from it. All right, angle C, side C is across from it. All right, so you can name a triangle whatever you want. It doesn't have to be ABC, right? You can name it ABC. You can call it DEF. You can call it RST. It doesn't really matter, all right? But whatever you name the angle, capital letter, the side across from it has to be that same letter in lowercase, all right? So uh, it's very important to kind of keep that in mind. Okay, so let's go ahead and work on this triangle. All right, so we know that this is 12.3. All right, and we know that angle A is 20 degrees. All right, so to solve the right triangle means we have to find all of its unknown parts, right? All of the missing parts. So we need to find angle B, side B, and side C. All right. And there's always multiple ways in which we can do this. One of them is going to be very easy. What is the very easy thing to find in this triangle?
B.
Yes, angle B, yeah. Right? Yeah. So remember, all angles of a triangle have to add up to 180, right? Exactly. We know that this is 90, all right? We know that this is 20, all right? So we do know that this must be 70 degrees. So B is equal to 70 degrees. All right, now from here, you kind of have some choices. All right, um, I'm going to go ahead and find side B first. All right, there's a couple of ways that you can do this. You can pick whatever angle you want. It doesn't really matter. All right. Um, Now, in the future, when you find angles, especially when we get to um, oblique triangles and we have to find angles, sometimes we'll be rounding them. Okay. So if you ever like round an angle, then you always want to use the angle that was given to you that's exact, right? Whenever possible, we always want to use exact measurements, right? But in this case, this is also exact, right? So it doesn't really matter which one you use here. I'm just going to go ahead and pick angle A because it was given to me. All right, so from angle A, I know side A, which is the opposite, right? I'm looking for B, which is my adjacent. From SOHCAHTOA, yes. All right. We were dealing with opposite and adjacent, so that is tangent. Remember, tangent is opposite over adjacent. So I know that tangent, and you don't have to write it down like this every time. This is just for explanation purposes, right? But tangent of angle A is going to be equal to the opposite, which is side A, right, over my adjacent, which is side B. All right. Well, I know that angle A is 20 degrees. So the tangent of 20 degrees is equal to A is 12.3, right? And B is what we're looking for. All right, well, as long as we only have one missing piece, we can go ahead and solve for it. All right, so first I'm going to go ahead and multiply both sides by B to get B out of my denominator here. All right, and then I will divide both sides by the tangent of 20. So B is equal to 12.3 divided by the tangent of 20 degrees. All right, so I will first pull up my handy dandy calculator. All right. Remember, we are dealing with tangent, our angle here, tangent of 20 degrees. So we do want to check and make sure that our calculator is in degree mode, and it is. All right. So here we said we wanted 12.3 divided by the tangent of 20. So 12.3 divided by the tangent of 20 degrees. And boom, 33.794 if we round. All right, now as a rule of thumb, all right, in my class, whenever you are finding sides, all right, round to 3 decimal places. Whenever you're finding angles, all right, we will round to 1 decimal place. All right. All right, so from a point 100 feet in front of a public library, the angles of elevation to the base of the flagpole and the top of the flagpole are 28 degrees and 39 degrees 45 minutes, respectively. Find the height of the flagpole. Okay, so it gives us these two triangles here. All right, so we'll work with them. Now, the height of the flagpole, right, if we call this whole side H1, and then this piece of the smaller triangle H2, how could I find the height of the flagpole? The height of the flagpole would simply equal H1 minus H2, right? The difference in these two heights, all right? So essentially, we're going to look at each triangle individually, right? This small triangle here, and then this bigger triangle here, to find my H1 and H2, and then I'll just subtract them to get the height of the flagpole. All right, so first I'll go ahead and find H1. All right, so let's just kind of look at it. Sometimes it gets a little, son of a biscuit. All right, sometimes it gets a little convoluted here when you have like multiple triangles overlapping each other. So sometimes it helps to just draw it separately. So we'll do the small one first, where this is 28 degrees. This is 100 feet. All right, and this is my H2, I guess. I'm looking at this smaller triangle. All right, so from my angle here, the piece I'm looking for is the opposite. the piece I know is the adjacent. So again, from SOHCAHTOA, what am I going to be using? Tan, right? So the tangent of 28 degrees is equal to the opposite over the adjacent. So to solve for H2, all I have to do is multiply both sides by 100. These cancel. All right, again, we can go to our handy-dandy calculator. We still want to be in degree mode since this angle is in degrees. So we simply say 100 times the tangent of 28 degrees. And we get 53.171. All right, I believe that was correct. Yes. Okay. So now we'll look at the bigger triangle, which is really going to look very similar, except now this is 39 degrees and 45 minutes. We talked a little bit about minutes, like degrees, minutes, and seconds. Who remembers how many minutes are in a degree? 60. Yeah, it's just like how many minutes are in an hour, right? Same thing. So 45 out of 60 actually reduces to 3 over 4, which, if you put that in a decimal form, is just 0.75, right? So that's really 39.75 degrees. We talked about how to do that in the calculator also. You definitely could have just said 39 plus, and then if you did, in this case, 45 minutes over the 60 that are in an hour, right, you get 39.75. So you can do that in your calculator as well. Anyway, this is my H1, and this is still 100 feet. So it really works the exact same way as this triangle. I just have a different angle, right? So I'm still dealing with my opposite and my adjacent, so I'm still talking about tangent. So the tangent of 39.75 degrees is equal to opposite over adjacent. So I multiplied both sides by 100. So we go to our calculator here. We say 100 times the tangent of 39.75. And we get 83.169. All right, so 83.169. Okay, now to cheat a little bit, all right, I know I'm subtracting these. I'm just going to say, okay, this is 83.17, and this is 53.17. All right, so now I know the height of the flagpole is equal to H1 minus H2. Exactly. So 83.17 minus 53.17. All right, so the height of the flagpole is 30 feet. All right, so nothing terribly complicated there, right? Just some SOHCAHTOA stuff going on. You just kind of have to be able to figure out, okay, if I'm looking for just the height of the flagpole, how do I get that from the information that I can find, right? So the math itself isn't very difficult. It's just kind of figuring out what you're really looking for. Okay, so those are some right triangles. All right, now we're going to talk about oblique triangles. All right, so it is super important, all right, to know that SOHCAHTOA and the Pythagorean theorem, a squared plus b squared equals c squared, all right, that both of these work for right triangles only. All right, do not try to use these with oblique triangles, okay? And also, unless you are explicitly told that a triangle is right, you can never just assume that it's a right triangle, right? If you aren't told that it's a right triangle, or if you aren't given that one of the angles is a 90-degree angle, it's not, right? I can't even count how many students on tests just assume that triangles are right. And I mean, 99.99999% of all triangles in the world are not right triangles, right? So please, please, please do not assume that they are. All right. So here it says the law of sines states that the ratio of the sines of an angle to the length of its opposite side is the same for all three angles of a triangle. So what that means is, okay, sine of angle A divided by its opposite side A is equal to the sine of angle B over the length of its opposite side B, which is also equal to the sine of angle C divided by its opposite side C. All right, so this is the law of sines. And it doesn't matter which way. Sometimes you'll see these flipped around, like the A on top and the sine of A on bottom. That's fine as long as they're all consistent, right? If you have sine of A on bottom, then sine of B has to be on bottom, sine of C has to be on bottom, right? So it doesn't matter as long as you're consistent there. I've seen some books have them the other way around. I've seen some books have them like this. It doesn't matter as long as you're consistent, all right? Now, the law of sines, will work for any triangle. All right, so you can use law of sines on right triangles. I see students do it all the time. That's perfectly fine. I mean, if you have a right triangle, SOHCAHTOA is always going to be the easiest way. All right, but if you want to use law of sines just all the time, that's perfectly fine. I've seen students do it. It will work. All right, this is just what we wrote down. Okay, this is just the kind of up here is the formal definition. All right, but this is what we wrote down. So if you already have this down, you're good. And it will be on a formula sheet that I give you for the test. You won't have to remember this. Not that it's difficult by any stretch of the imagination, but that'll be given to you. Okay, so angle, angle, side, and angle, side, angle, right, which we call AAS and ASA. All right, so two angles and a side of a triangle in any order determine the size and shape of a triangle completely. All right, these were two of the cases that you would have been allowed to use in proving triangles congruent in geometry. All right, do we all remember proving triangles congruent in geometry? All right, these were two of the ones that we were allowed to use. We were also allowed to use side, 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 and side, angle, side, which is the one we were not allowed to use. Angle, 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 you can't use to solve, to prove things congruent. That is correct. You can use it to prove them similar. Not quite. Side angle, angle is fine. That's the same as angle, angle, side, actually. It can spell a bad word. Yeah, angle, side, side, or side, side, angle. All right. I always say it angle, side, side because I always tell my kids in geometry, right, that if you try to use ASS to prove triangles congruent, you will just make an ass out of yourself, right, because you can't do it. So that's how I always, tell students to remember that. However, we will actually discuss that in detail tomorrow about, why you weren't allowed to use it. And we'll kind of talk about it and actually use it a little bit tomorrow, but that's getting ahead of ourselves. All right. So for the law of sines, all right, you can like whenever you have this case, all right, you can always use law of sines. So use law of sines. for angle, angle, side, and angle, side, angle. All right, now, hopefully you all remember what angle, side, angle and angle, angle, side, and that stuff really means, but just as a quick refresher. All right, so if we have a triangle, and just for argument's sake, I'll call this ABC. So this would be side A, side B, and side C across from their respective angles, of course. All right, angle, angle, side, right, would be, for instance, if I had angle A, angle B, and side A, right? That would be angle, angle, side. Okay. Also, if you had, right, angle, side, angle, right? This would be ASA because I have an angle, a side, and an angle, right? So a side between my two angles. All right. So do kind of remember how all that means, right? Typically, you'll always be given three sides, right? So if you just like pick any three random pieces, right? Start with one, and then just kind of go to the closest one. So like here, you would have side, side, angle, right? Or angle, side, side. So that's that case that we were talking about where, okay, you weren't allowed to use that to prove two triangles congruent. All right. Or if you have, bam, 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 right? That's side, angle, side, right? So that would be SAS. We'll get to all of these later, but just kind of a little review on how you get these, what cases you're talking about, okay? All right. So let's solve triangle ABC, given that angle A is 36 degrees, angle B is 48 degrees, and side A is 8. Yep. All right. Now, delta math just asks you to find one specific piece, whereas here it says to solve the triangle, which means we're trying to find all of the missing pieces. All right. So the delta math stuff will actually be a lot quicker than one problem that we do here. Okay, you would just have to find one piece. Okay, so angle A we know is 36 degrees. All right, angle B we know is 48 degrees. And side A is 8. We don't know whether it's inches, feet, miles, doesn't matter, 8 units. Okay. Now, whenever you're given two angles, the third angle is always the easiest thing to find, correct? Right, so if we add these together, that's 84. We know that they all have to add up to 180. So if you do 180 minus 84, that will tell you that this is 96. Good times? Okay. So now, all right, remember, this is not a right triangle. All right, we cannot use SOHCAHTOA. We cannot use the Pythagorean theorem. Yes, we have to do the law of sines, okay? And it doesn't matter here whether we find B or C first, right? Those are our two missing pieces, right? But we are always going to have to use sine of A over A. All right, now it's very important to note, I don't feel like I should have to say this, but I really do every semester because inevitably some student will try it, all right? When it says that these three things are all equal to each other, we're only using two of them at a time. Do not try some super formula where you write all of this out at once, okay? You're either going to say sine of A over A equals sine of B over B, or you can say sine of A over A equals sine of C over C, or you can say sine of B over B equals sine of C over C. Okay, you can never use all three letters at once. All right, are we all clear on that? Okay, please do not be that student. I usually have 2 or 3 of them every semester that tries some mega super equation and obviously misses things pretty severely. All right, so here, the only letter in which we have both the angle and the side is A. So we have to use sine A over A. Have to. All right, and it is also important to remember that the capital A always goes with the sine. Right? Remember, we talked a lot about sine of theta, and we said theta always has to be an angle, right? So sine, regular trig function, sine, cosine, tangent, they're always going to be attached to an angle. Okay, so don't flip these around. If you do sine of lowercase a over capital A, you will be very, very, very wrong. Okay, it will mess things up dramatically. So do keep that in mind. All right, now it doesn't matter whether we find B or C first. I like to go in alphabetical order, so I'll just say that it equals sine of B over B. All right, so now I can just fill this in. All right, so my angle A is 36 degrees. All right, my side A is 8. All right, my angle B is 48 degrees. And I don't know my side B. Okay, well, here, the easiest way to solve when you have a variable in the denominator like this is to just cross multiply. Okay, whenever you have one fraction equal to another fraction, you can cross multiply. So you'll end up getting B times the sine of 36 degrees is equal to 8 times the sine of 48 degrees. Yep, we can just simply divide by the sine of 36 degrees. All right, so when we do that, no, that's not that at all. All right, so we can say 8 times the sine of 48, all right, over the sine of 36. Boom, 10 point, this is a side, so I'm going to round it to 3 decimal places, 10.115. All right, so now we have found 2 of our 3 missing pieces. All right, so now we just need to find our side C. Okay, again, this is not a right triangle, so do not do a squared plus b squared equals c squared. That will not work in this case. All right, so again, we're going to want to use a law of sines. All right, now we have b here, so technically you could say sine of b over b equals sine of c over c, but why might we not want to use this? You're right, it wasn't given to us, and it's not exact. We had to round this, okay? You can use this and get a fairly exact answer if you actually use the entire calculator, right? Like if you used 10.11450794, all right, then it would work close enough, even though this is still rounded, but it's rounded to so many decimal places that it would definitely be accurate enough for us, okay? But if you just use this value here, and then you use that in another law of sines, and then you round that answer because you used a rounded answer, and then you rounded that answer, you might actually be off a little bit, like when we round it to 3 decimal places. So do be very mindful of that. So we were given angle A and side A, so we always like to use that. So sine of A over A. In this case, we're looking for side C, so we use sine of C over C. All right, so again, we have sine of 36 over 8. All right, but now we have sine of 96 over little c. Yep. So again, we can cross multiply, and we will get c times the sine of 36 is equal to 8 times the sine of 96. And of course, we can just divide both sides by the sine of 36 degrees. These will cancel. So we will get C is equal to, we can use our calculator again. All right. So we can say 8 times the sine of 96 divided by the sine of 36. Boom. 13.536 if we round. So there are all three of our missing pieces. We have solved the triangle. All right. Now, sometimes it helps to just kind of check to see if your answer makes sense. Right. Now, it's not going to tell you that this little method here isn't going to tell you whether you're 100% right or not. Right. But it does help to know whether or not your answer makes sense, which sometimes can help you realize that you're in the wrong mode. Right. Like if you're just kind of turned on your calculator and it was in radian mode instead of degree mode. Right. Sometimes this little trick can help out. If you remember from geometry, all right, that the longest side should always be across from the largest angle, and the smallest side should always be across from the smallest angle, right? So we know that C is our largest angle, so C should be my largest side, is it? Yeah, right. 13.536 is bigger than 10.115 and bigger than 8, right? 36 is our smallest angle, so it should be across from my shortest side. Is 8 my shortest side? Sure is, right? So that just tells us that our answer at least makes sense. It doesn't tell us for sure that we're 100% correct, but it does tell us that our answer makes sense. Okay. So that's just a good little trick to kind of check every time you solve a triangle to make sure that it makes sense. Go ahead and try this one. It will work very similarly.
Is it fine if we do it like sine B would be equal to sine A over A?
Yeah, absolutely. Yep.
I want to make sure we work.
Yeah, no. Equations are always go both ways. Right. That's the beautiful thing about an equal sign. Right. Like 2 plus 2 equals 4. Or you could just as easily write 4 equals 2 plus 2. Right.
Thank you.
Okay, so let's go ahead and take a look. Once you kind of get the hang of these, they go pretty quick. I know I took a fair amount of time on the last problem, but that was really more just for a very thorough explanation's sake. All right. So here I've filled in all of the pieces that were given to us. Of course, whenever you're given two angles, the easiest piece to find is your third angle. So 40 and 30 make 70. So if we all have to add to 180, then this has to be 110. Obviously not drawn to scale, right? So now we just go ahead and use our law of sines, right? We're missing A and C, right? Uh, so we know that we're going to have to use sine of B over B, right? So yeah, so absolutely. So sine 30 over 10. And then it doesn't matter whether we find A or C first. I'll just go ahead with A. So sine of angle A, which is 40, over side A. All right, so then of course I cross multiply. All right, and when I do that, I'll get A sine 30 over 10 sine 40. And then to solve for A, I'll divide by sine 30. So A is equal to 10 sine 40 over sine 30. And then we can go ahead and plug this into our calculator. So 10 sine 40 over sine 30. Boom. All right, 12.856. And of course, we already found here that C is equal to 110 degrees. All right, so now we just need to find side C. Again, we want to use whatever's given to us. So in this case, we'll use our B's. All right, so sine of 30 over 10 again is now equal to sine of C, which is 110 degrees. All right, over side C. Again, we can cross multiply and then divide by sine 30. So C is going to equal 10 sine 110 over sine of 30.
18.79.
I'll believe you. 18.794, you said? All right. All right. And of course, this does make sense, right? C is our largest side, all right, which is across from our largest angle. All right, B is my smallest side, and B is my smallest angle. So all makes sense. Again, doesn't for sure tell us that we're correct, but we can feel pretty confident there. Okay. This is the exact same thing. Do we really need to do another? No, probably not. All right. So let's kind of look at it in a word problem sense. All right.
There could be word problems on Delta Math or just.
No, not on Delta Math. Two observers are 600 feet apart on opposite sides of a flagpole. The angles of elevation from the observers to the top of the pole are 19 degrees and 21 degrees. Find the height of the flagpole. Okay, so You will have a problem almost exactly like this on the test. All right. It may not be a flagpole. I think it might be an airplane in the sky or something like that, but it's the exact same concept. All right. So we have two observers 600 feet on opposite sides of the flagpole. Right. So there's a flagpole somewhere here. All right. So, and they're looking the angle of elevation from them to the top of the flagpole. All right. And one of the angles um, is 21 degrees.
Does it matter how we put it on?
Not really. And the other is 19.
And it's 600 feet across the bottom, right?
Exactly. Okay, now, the flagpole is not directly in the center. How do I know that?
Because the different degrees.
Yes, because these angles are different. All right. The only way that this flagpole could be right in the middle,
It was like 2020.
exactly, all right, is if these two were the same. If this were an isosceles triangle, all right, it is not. All right. Therefore, you also cannot say, I have students do this every test, every year, all right, is they just break this up in half. They're like, oh, this is 300 feet and this is 300 feet. No, right? Again, the flagpole is not right in the middle. We don't know, okay? And we don't really care to know. We don't need to know, okay? Um, we want to know the height of the flagpole here, all right? Now, but before we can do that, all right, we actually need to find either this side or this side. Son of a biscuit. Okay, you don't need both, just one, all right? Now, how could I do that, all right? Lots of students try to jump right to finding the height. You can't. All right. There is no way to just magically find the height right now. Okay. You have, like I said, you either have to find this side first or this side first. And what have we been talking about today? What was the new thing that we've talked about today? Yeah, law of sines, right? Law of sines. So we definitely want to use law of sines. Well, instead of thinking about this height, right? And I know that that's what we're ultimately trying to get to. So every student wants to think about it. Ignore it for the time being. All right. Think of this big triangle. Okay. So we have two of the angles of the big triangle. So can't I find this angle?
Yes.
Yes. Right. 21 and 19 are 40. So this big angle up here has to be 140. All right. So now we can use law of sines. All right. Of course, I would have to call this x and this y if I call these x and y. And just for fun's sake, I'll call this angle z. All right. So now I can do either sine of x over x equals sine of z over z, or I could do sine of y over y equals sine of z over z. Now I have to use z, right? Because z is the one where I have the angle and the side. Okay. Um, which one do you want to find, x or y? It doesn't matter. X, sure. All right. So we'll say sine of z, which is 140, all right, over side z, which is 600, has to equal sine of angle x, which is 19, over side x, which is what we're looking for. Again, we can cross multiply, divide by the sine of 140. So x is going to equal 600 times the sine of 19 divided by the sine of 140. Right, so again, we can use our calculator here. We can say 600 times the sine of 19 degrees divided by the sine of 140 degrees, and we will get 303.896. Okay, so now that we have one of these sides, now we can talk about this height, all right? Well, since we found x, I'm only going to concern myself with this triangle, all right? Yes, we can say that that is a right triangle, assuming that the person who put the flagpole up was not like, severely impaired somehow, right? We would assume that they would like to put the flagpole straight up and down, right? Yeah, we hope so. We don't want any leaning tower of Pisa, situations going on, right? So we can assume that that is a right triangle. All right, so here we can just kind of think of this as this right triangle, right? And we have 21 degrees, and we know that x is 303.896, right? And I want to find this height here. All right, well, since this is a right triangle, I can use SOHCAHTOA. All right, so here is my angle that I'm worried about. I'm looking for my opposite side, and I have my hypotenuse. Which trig function deals with opposite and hypotenuse? Sine, right? So I know that sine of 21 degrees is equal to h over 303 point dot dot dot, right? So how would I solve for h here? Multiply both sides by, 303 point whatever, all right? So, and remember, we don't like to use rounded things, all right? But we have to here. So what am I going to do? I'm actually going to use this whole piece instead of just 896. Does that make sense? All right. So in a real easy way to do it, especially when it's already in your calculator, right? All I have to do is hit times, and it's going to say, okay, I'm going to take your most recent answer times, and now I want to do sine of 21 degrees. So this is 108.907. Yeah, 108.907, I believe. And this would be feet. Good times? Yeah. That's a very tall flagpole. Yes, 100%. You would definitely notice it. It's like one of those giant flagpoles that they have, like huge venues. Yeah, you can't miss one of those things. Right.
And Boy Scouts who have to laugh together flagpoles out of wood, and my group got disqualified because apparently your flagpole has to go straight.
Right.
You should go like this.
Nice. Very nice. So this was not your flagpole. Okay. A Ferris wheel has 16 evenly spaced cars. Right. The distance between adjacent cars is 15.5 feet. Find the radius of the wheel to the nearest tenth of a foot. All right. So this is a problem that typically kind of confuses students a little bit. All right. But let's go ahead and do a circle here. All right, so here is my Ferris wheel. All right. Now we have 16 evenly spaced cars. All right. I'm not going to draw all of the cars by any stretch of the imagination, but we can have a car here, and a car here, and a car here, whatever. All right. So here's a few cars. There's going to be 16 of them total. All right. Now, let's think of these as radii, right? So from the center of my circle to this car, and from the center of my circle to this car. Right, now we really only need 2 cars on here. I don't really need to draw this, all right? But, all right, we can actually think of this, even though it's on a circle, as a triangle, yes?
Yes.
All right, so it tells us that the distance between adjacent cars is 15.5 feet. So I know this is 15.5. All right, now we are trying to find the radius of the wheel. Well, this is r and this is r, right? Those are both radii. Okay, now we don't know any angles, and we obviously have to know angles, right? Does anybody know how to do that?
360 degrees divided by 16.
Absolutely. And that will give me this interior angle here. All right. So 360 divided by 16 will give us 22.5 degrees. All right. So we know that this is 22.5 degrees. All right. Now we know that in order to use law of sines initially, we need to have 2 angles, right? We talked about angle, side, angle, and angle, angle, side. All right, well, can I find these other 2 angles?
Yeah.
Why?
Because they're the same.
Yeah, why are they the same? Because of these, right? These, the radius of a circle is constant, right? So this radius has to be the same as this radius, which means this is what kind of triangle? Isosceles, right? Whenever you have a triangle with 2 congruent sides, that's an isosceles triangle. And an isosceles triangle, the base angles are congruent as well.
So I have to do is 180 minus 22.5 and divide by 2.
Exactly. So we say 180 minus 22.5, and then we divide that by 2.
78.75.
Sweet. All right, so 78.75 degrees. All right, so both of these, it doesn't matter which, right, are 78.75 degrees. Okay, well, now I have an angle with its opposite side, and I have another angle with the side that I'm looking for, right? Because I'm looking for the radius. So now I can set up a law of sines here. I can say the sine of 22.5 divided by 15.5 is equal to the sine of 78.75 divided by r. Make sense? All right, so now, of course, we just cross multiply, divide by the sine of 22.5. So r is going to equal 15.5 times the sine of 78.75 degrees divided by the sine of 22.5 degrees. So we plug that into our handy dandy calculator. And we get 39.725. And that would be feet. So there is our radius. Good times? Fantastic. All right. I believe that is it. Yep, of course. course, your homework is on Delta Math and not in your textbook. So that is it for the day. So I will go ahead and